In previous class, we have already discussed what is the difference between the relation and function, why all the relations are not function, but all functions are relations, definition of the functions and notation of the functions. Today, we shall discuss about the different type of functions. Very important chapter, and these are the fundamentals of mathematics. We have to remember these basic fact about the mathematics. First, we shall discuss about the constant function. Constant function. Constant function. Suppose A and B are any two sets, and we define a function f from A to B. If the range of the function is a singleton element, if the range of the function is a singleton element, then the function is said to be a constant function. Diagrammatically, we represent as, suppose A contains 3 elements and B has 4 elements, but all the elements of set A are connected with only single element. Here the range of the function is a single element, so this function is known as constant function. So constant function means whose range is a singleton element. We have already basic idea about the domain and range. In a relation, every element of set A are the elements of the domain, and the elements of B which are associated with set A are the range of the element, but total set B is the codomain. That is the basic difference between codomain and range. All the elements of B are not range, but all the elements of B are in codomain. The elements which are associated with are the image element of set A are known as the range. So a function f from A to B is said to be constant function if each and every element of set A has only one image element in set B. That is, f of A is a singleton set. Means that is range of a function is a single element. That is the constant functions. Means constant quantity means who never changes. For any value of x, if the value of fx is a fixed point, then the function is known as constant function. For example, suppose f of x equals to 3. For all x belongs to R. This symbol is for all, or for every. This symbol stands for all or for every. Here the range of the element is 3, so it is a constant function. So a function is said to be constant function if its range is a singleton element. Means only 3 is the range of the function. It may be 3 or maybe 1 or maybe 0, any real number. Then the function is said to be a constant function. Graphically, constant function is always parallel to x-axis, y equals to constant. This is the graphical representation of constant function. Constant function is always parallel to x-axis. For every value of x, there is only one image element. Then the function is known as a constant function. Here a domain is any real number, but range is a fixed element. Any fixed real number. So then the function is said to be constant function. Okay? This is a big chapter. We have to proceed slowly and thoroughly. We shall discuss all the functions, constant functions, identity functions, exponential functions, logarithm functions, rational functions, trigonometric functions, signum function, modulus function, greatest integer functions. So we proceed slowly. You have to cooperate with me, then we will discuss properly. Then next we shall discuss identity function. Identity function. These are the basic of the mathematics. Identity functions. A function is said to be identity functions if each and every element is associated with itself. Means, suppose this is set x and this is also set x, and we take a function f from x to x. If here x1, its image is x1, x2, its image will be x2, x3, image will be x3, then the function is said to be identity function. Means each element is image element of itself. Every element of x is image element of itself. Means domain and range are equal. Then the function is said to be identity functions. A function f from x to x is said to be identity function if each and every elements of x is the image element of itself. Image element of itself. Each and every element of x is the image element of itself. Then the function is said to be identity function. That means f of x equals to x for all x belongs to set x. That is the definition of the identity function. We denoted it as IDX. This is the representation of an identity function. Means it is an identity function from set x to set x. Its domain is also set x, range is also set x. Domain and range are equal. Then the function is said to be identity functions. Always this set is domain set and range is the proper subset of this set. This is the graphically representation of the identity function. Suppose this is set x and this is set y and its origin. So this is the graphical representation of the identity function y equals to x. Because f of x is equal to x means y is equal to x. Always the line y is equal to x passes through origin. So this is the graphical representation of identity functions. This all about the identity functions. Basic fact. Always it will be necessary for our subject. Next, rational functions. Next we shall discuss about the rational functions. Rational functions. A function of the form px by qx. A function of the form px by qx is called, is or are called rational functions. Rational functions, where p of x and q of x are polynomial functions. Polynomial functions. What do you mean by polynomial functions? Means px may be written as this form: a0 x to the power n plus a1 x to the power n minus 1 plus dot dot a n. This is a polynomial function of degree n. Polynomial function of degree n. So a function of the form px by qx, we know all about the rational numbers. That is, the number which expressed as the form p by q is known as, where q not equal to 0 is known as rational number. Same concept. Here px and qx are the polynomial functions and qx is not 0. Then the function is said to be a rational functions. And there are two types of rational functions. One is improper and another is proper. Improper and proper. Improper and proper. Proper means if the degree of px is less than degree of qx, then it is called proper rational function. Degree of px less than degree of qx, then the rational function is called proper. For example, 2x plus 1 by x square plus 6x plus 7. This is a proper rational function. Here px is a linear polynomial. Linear means whose degree is 1. So px is 2x plus 1. It is a linear polynomial, but it is a quadratic polynomial. So degree of px is less than degree of qx. So it is a proper rational functions. These are the basic idea. We have to remember always. Next, improper. Degree of px greater than or equal to degree of qx. Then it is called improper rational function. Means, for example, x cube plus x square plus x plus 1 by x minus 1. This is an improper rational function because here the degree of px is 3. Degree means the highest power of x. Here the highest power of x is 3. So px is a polynomial of degree 3, but qx is a polynomial of degree 1. So it is an improper rational function, but this is a proper rational function. Suppose x square plus x plus 1 by x square minus x plus 2. This is also improper because here the degree of px equals to degree of qx. So this is also improper rational functions. These are all about the rational functions. So rational function means the functions which express of the form px by qx. And the rational functions are divided two categories. One is proper and another is improper. If the degree of px is less than degree of qx, then it is called proper rational function. If degree of px greater than or equal to degree of qx, then it is called improper rational functions. Next, modulus function or absolute value functions. Modulus functions or absolute value function. Absolute value function. It is a very important functions. In mathematics, absolute value functions is a very important functions. Every day we will be familiar with this type of functions. Absolute value functions, a function f from R to R defined as f of x equals to mod x. This known as mod x. We read as mod x. A function f from R to R defined as f of x equals to mod x, where mod x will be x if x greater than equal to 0 and minus x if x less than 0 is called absolute value function or modulus function. Very important functions, basic fact of the mathematics. Modulus functions. And another function is greatest integer functions. Mod x will be x when is x greater than equal to 0. For example, suppose 3 mod. Here x is 3 and we know that 3 is greater than 0. So the mod of 3 will be 3. So mod of 3 will be 3. By definition, mod x is x if x is greater than equal to 0. Next, suppose minus 3 mod. Here x is minus 3. So its mod will be minus x. Means minus x is minus 3. That will be plus 3. So mod 3 equals to minus 3 for this by according to definition. Because here x is minus 3. It is less than 0. Oh, you have to move this fact. That is minus x means minus x is minus 3. That is plus 3. So the mod of minus 3 is also 3. That is the definition of the modulus functions. For example, suppose x minus 1 mod for x is less than 1. Here x is less than 1 means x minus 1 is less than 0. So mod of x minus 1 will be minus of x minus 1 because here x is negative. X means the number which is within the mod, that is x. Here x is x minus 1 and that x minus 1 is less than 0. So its modulus will be minus x means minus of x minus 1. If x is greater than 1, then mod of x minus 1 will be x minus 1. That is the definition of the modulus function. So its domain will be real number. All real number are the domain of the absolute value function. And range will be positive real number union 0. Its range cannot be negative. Range means the output. Domain means the input. Here x is the domain and the output is range. As the modulus will be always positive for the real number, so it will be positive real number union 0. But domain is real number. That is the modulus function. And its graphical representation is like that. This is mod x, y equals to mod x. Because if we draw the number lines x and y, if x is 0, y is 0, x1, y1, x2, y2. If x minus 1, y1, if x minus 2, y2. So it lies in first and second quadrant. Means when x positive, y will be positive. When x negative, y also positive. That means it is a straight line that is in first and second quadrant. That is the graphical representation of the modulus functions. This is all about modulus functions. You can go through your textbook for detailed study. Next, signum functions. Signum function. The signum function of x denoted as Sgn x. This is read as signum function of x, which defined as Sgn x equals to x by mod x when x not equal to 0 and 0 when x equals to 0. This type of function is known as signum functions. Means x by mod x when x not equal to 0 and 0 when x equals to 0. We have to remember this only. This type of function is known as signum function. But we have to remember this type of function is known as signum function. Its domain will be any real number. Domain means the input, the number which we have to put here, that is the domain, and the outcome are known as range. So range will be, suppose we take here 1, then 1 by 1 will be 1. Suppose we take 2 by 2 mod is 1, 3 by 3 mod is also 1. So its range will be -1, 0, 1. If we take -3, suppose we take -3, here -3 and mod of -3 is 3. So 3 by -3 is -1. Only 3 numbers will be output. That is 1, 0, -1. 0 for x when x is equal to 0. For otherwise non-zero value, the outcome will be for positive is 1, for negative is -1. So only 3 outputs, -1, 0, 1. This is the range of the function and R is the domain of the function. This function is known as signum functions. Next, greatest integer functions. Greatest integer function. A function f of x defined as f of x equals to bracket x. We read as bracket x, bracket of x. A function f of x defined as bracket x is known as greatest integer function. Greatest integer function, which defined as f of x equals to bracket x means the largest integer less than or equal to x. The largest integer less than or equal to x, that is known as bracket x. We read as bracket x, that is greatest integer function of x. That means f of x will be 0 when 0 less than equal to x less than 1. 1 when 1 less than equal to x less than 2. 2 when 2 less than equal to x less than 3. N when n less than equal to x less than n plus 1. This type of function is known as greatest integer function. For example, suppose 3.4 bracket value of 3.4. Here x is 3.4. Then the output will be 3. The largest integer which is less than 3.4. It will not 2 because 2 is less than 3. The largest integer which is less than 2.4, 3.4. The largest integer which is less than 3.4, that is 3. That is the output of the greatest integer function. Suppose it is 2.9, then it will be 2. Suppose it is 1.65, then it will be 1. Suppose it is minus 1.7, then it will be minus 1, not minus 2, because minus 2 is less than minus 1.7. Because we have to take the largest integer, that is less than x. Here x is minus 1.7. So it will be minus 1.7, that is minus 2, not minus 1. That is the largest integer less than or equal to x. Largest integer less than or equal to x. That is known as greatest integer function or bracket functions. Its domain is any real number, but its range means the output. Range will be only z set, means only integer. The output will be only integer. That is the domain and range of the greatest integer functions. This all about today. We discussed constant function, identity function, rational functions, modulus functions, bracket function, signum function. In next class, we will discuss all other functions. First, you go through your textbook and thoroughly read. Then we shall discuss in next class other functions. Thank you all.